Find the value of x and y. Triangle. And they're telling me this is a right triangle. And from the right angle, I'm constructing my altitude to the opposite side. And they're telling me that one side, this one here is 6. This small side here is x. And they also say that this side is 9 units long, and this side here is 1, right? Now, the way I put this triangle on the board is kind of you know, giving this triangle as an isosceles triangle, but it's not, okay? I mean, if they're giving you a problem, a geometry problem, and you have this figure in front of you, yes, do not assume that that figure is what you believe it is until you can prove it, and until, you know, all the facts together will sustain that kind of opinion that you may have. It may look like an isosceles triangle, but that triangle may be, you know, a different type, a different kind. Good. Now, from the given facts here, and you know what, I will label this triangle A, B, and C, and the point of intersection of your altitude, and AC will be B, right? That's going to help me. And I have to find the missing sides, right? So, how can we do it? How can you start? What statements will you guys use? And remember, this is chapter 9.1. We're basically dealing with similar triangles in the right triangle. Which ones can you use? What statements can you use? And if you don't remember them, if you cannot recall them, at least you can try to find similarity statements here. All right. So which triangle would you like to start with? Or what will be the first step? Which one of the two variables can you find right away without actually using any similarity statement? Can you find anyone? And triangle ABC is what kind of triangle? Triangle ABC. It's right. Which means what? What theorem can you apply here? It's the right triangle. Pythagoras theorem, which says what? The square of the longer side, in this case AC squared, will equal the sum of the squares of the shorter side, right? Equals AB squared plus BC squared. Now I know AC, I know BC. Let's substitute those sides with their value, right? AC is 9 squared, which would equal AB, which is y squared, plus BC squared, which is 6 squared. To find y, you will subtract 6 squared from both sides. So you have y squared equals 9 squared minus 6 squared. And that will be 81 minus 36. Okay. And that makes your y squared equal to what? Well, 6 out of 11 will be 5. 3 out of 7 will be 4. To find y, you will take the square root of both sides, and your y equals 1. Square root 45 is actually square root 9 times 5, which equals square root 9 times square root 5, and that will be 3 square root 5. And that's your first answer. y equals 3 square root 5. So I know this side here is 3 square root 5. Which other sides can I find now? Well, think about similarity statements. I know triangle ABC will be similar to what triangle? Well, definitely C will be the last angle in here. I'm looking at this triangle here, right? BDC, but I'm not sure in which order I have to write this vertices, such that you know the two triangles will be similar, and I will write the similarity in the proper order. But I know C has to be the latest one, right? I know in the middle I will have the 90-degree angle, and that will be D. So this is the statement you have to write. Triangle ABC, the big triangle, will be similar to the triangle BDC, because we know this angle here, DBC, is definitely congruent to A, because angle C is a common angle in the two triangles, and then you have the 90-degree angles, right? This is your similarity statement. From this one, you can write the similarity ratios, right? Which are looking like what? Who can help me? What side over what side equals what side over what side, and so on. What side over what side from the second triangle equals what side from the first one over what side over from the second one, and so on. Who wants to try? A triangle. Let's try with AB. AB. AB over what in the second one? Well, AB is opposing the 90-degree angle. Which one opposes the 90-degree angle in the other one? AB. I mean, hold on, no. AB opposes the angle C in the big triangle. I was looking at the small triangle. AB opposes angle C. Which one opposes angle C in the second triangle? BD. BD. I'm going with the next side. I mean, basically, I'm following the order in which the triangles are written, right? AB was over BD. BC over what? DC. And you can check. BC opposes angle A. Well, DC also opposes an angle that's congruent to angle A in the small triangle BDC, right? And then the last side, AC, which opposes a 90-degree angle in the big triangle ABC, over the one that opposes, you know, the 90-degree angle in the small triangle BC. And this is your similarity proportion for the two triangles, right? Hold on. I'm going to take this away. Let's substitute everything that we know. Okay? This is equivalent with the following statement. AB. How big is AB? AB is y, which is how big? 3 square root 5. Over BD. Do we know how big is BD? No, we don't know, right? Equals, second statement, BC, which is 6, over DC. DC is x. We don't know that, right? And equals AC. AC we know is given is 9 over what? Over BC. And BC is 6. Looking at your similarity proportions here, which one can you use to find a missing side? Well, I don't have to find BD, so I don't need that, but I need to find X, and I can use the last two ratios here, that proportion in yellow. And from that one, using the cross products, what is the equation that you can write? Well, you can go with this first, with this cross product first. X times 9, or 9x, equals the other cross product, 6 times 6, which is 36. solve for x dividing both sides by 9. What do you guys find? X equals 1. X equals 4. Are we done? Well, the problem said find each variable and was only x and y, but if you want you can solve everything here. You can find what is BD, you can find AD obviously now will be what? How big is going to be AD here? Knowing that x is 4. How big is AD? 5, right? That's obvious. And this is it.